Hello, I'm Professor Kitch, and welcome to my series of geotechnical engineering webcasts. This webcast is an introduction to drilling and sampling. The purpose of this presentation is to provide an overview of common drilling and sampling techniques. It's intended to supplement presentations using photographs or videos of drilling and sampling. While photos and videos of drilling and sampling operations can show you the equipment being used, they can't show you what's going on below ground. This presentation uses animations of drilling and sampling operations to demonstrate what's happening below the ground. At the end of this video, I'll provide some links to other videos that show actual drilling and sampling being done in the field. This presentation will cover common types of drill rigs, the four most common drilling techniques: solid stem augering with the open hole method, hollow stem augering method, the wash boring method, and the casing method. It will also cover the basics of pushed and driven samplers. There are a number of types of drill rigs available. Some of the most common are large truck-mounted rigs, sometimes called highway rigs, off-road track-mounted rigs, and trailer-mounted or portable rigs. Different rigs are suited for different site conditions and different drilling and sampling methods. The large truck-mounted rig is the most versatile and one of the most common drill rigs used. However, it can only be used in situations where it can be driven onto the site. The process of drilling is similar regardless of the type of drill rig used. First, we position the rig over the location where we wish to drill. Then we erect the drilling boom or mast and make sure it's vertical. A drill head mounted on the boom is the mechanism used to perform the drilling and sampling operation. The drill head provides two motions to aid in drilling. A torque can be applied to rotate the bit, and a vertical thrust can be applied to raise and lower drill bits and other equipment. There are many different drilling and sampling techniques we can use to investigate the subsurface conditions. One of the simplest is the open hole method using solid stem continuous flight augers. The flights on a continuous flight auger run the full length of the auger. At the tip of the auger is a cutting bit. The inset photo shows two different diameter solid stem augers with two different types of cutting bits. The auger is rotated and pushed into the ground by the drill head. The bit at the tip of the auger loosens the soil at the bottom of the hole, and the flights carry the cuttings to the ground surface. An engineer or geologist can estimate when new soil layers are encountered by observing the changes in the cuttings as they're brought to the surface. These cuttings can be collected as bulk samples. However, they are low quality samples because they're completely disturbed by the cutting process and because soil from the upper layers can contaminate soil from the lower layers as the cuttings are carried up the auger flights. When the boring reaches a depth where a higher quality sample is desired, the auger is removed from the hole to make room for the sampling equipment. In this method, the borehole must be able to stand open without support, which is why we call it the open hole method. When we wish to take a sample, we replace the auger bit with a sampling tool or sampler. Nearly all soil samplers consist of some sort of hollow tube which is inserted into the soil to retrieve the sample. There are many different designs of samplers to suit different soil conditions, but the basic process of sampling is similar for most of these samplers. The sample tool is lowered to the bottom of the boring and then pushed into the soil below the bottom of the boring. When the sampler has reached its full depth, the rods are twisted to shear off the bottom of the sampler, and the sampler containing the soil sample is retrieved from the boring. The sample is then stored for later analysis and testing. The sampling tool is replaced with the auger, and the auger lowered back down the hole. Augering continues until we reach a new layer where we wish to take another sample. The auger is then retracted from the hole and replaced by the sampling tool, and another sample is taken using the same process. When the soil is very stiff or dense, it's not possible to use a push-type sampler. In these circumstances, we use a heavy-walled sampler that can be driven into the soil using a drop hammer. The process is similar to retrieving a push-type sampler, but uses different equipment and a different sampler. The open hole method only works if the soil is stiff enough and strong enough to remain open after the augers are removed. While it is often possible to use the open hole method, many times the soil is not able to maintain an open hole for sampling. If the soil is soft, it may squeeze into the boring when the augers are removed. This often happens in a soft clay layer. If the soil is a clean sand with little or no cohesion, the soil at the sides of the hole may cave or fall into the boring. This is particularly a problem when drilling in sands below the water table. When squeezing or caving conditions occur, we must use a different drilling method that will support the borehole during the sampling process. One method that can be used in caving or squeezing soil conditions is the hollow stem auger method. In this method, we use a continuous flight auger as in the open hole method, but in this case the auger stem is hollow. The bit in the center of the auger is retractable and can be removed through the hollow stem. The inset photo shows a hollow stem auger and its retractable center bit. For illustration purposes, the center bit has been removed and is shown next to the hollow stem auger. During drilling, the center bit is inserted inside the hollow stem. The augering process proceeds in the same fashion as with the open hole method. When we reach a depth at which we wish to take a sample, we stop augering, detach the center bit from the auger and remove it. The auger remains in a hole and supports it. We can now acquire a sample through the open hollow stem. The sampling process is the same as we used before. After sampling, the drill bit is replaced and augering continues. The rotary wash boring is another common drilling method. Instead of using an auger to remove cuttings from the hole, this method uses a slurry or drilling mud to flush cuttings out of the hole. The drilling mud or slurry is a mixture of either bentonite and water or a polymer and water. The purpose of the bentonite or polymer is to increase the viscosity of the slurry, which makes it easier for the slurry to carry the cuttings to the surface. Special equipment is needed to handle the drilling mud, including a holding tank, a pump, and a swivel head. The pump circulates the drilling mud from the holding tank through the swivel head into the top of the drilling rod. It then goes down the hollow stem inside the rod toward the cutting bit. The boring is advanced using a drill bit at the bottom of the hole. The drill bit or cutting bit is turned by the drilling head and loosens the soil at the bottom of the hole. The drill bit contains ports that allow the drilling mud being pumped down the hollow stem to exit out the sides of the bit into the annular space outside the drill rod. The mud flows up this annular space and carries cuttings away from the bit and out the top of the hole. The cuttings settle out of the drilling mud in the holding tank, and the clean mud is recirculated back down the drill rod. Driving the drill bit of a rotary wash boring takes much less energy than driving a long continuous flight auger. Therefore, rotary wash borings can advance much more quickly and reach greater depths than auger borings. In addition to flushing cuttings from the boring, the drilling mud also provides a hydrostatic pressure along the sides of the drill hole. This can help to stabilize the hole and allow drilling in moderate caving conditions. When we reach our desired sampling depth, the drilling is stopped and all of the cuttings are flushed out of the boring. The pump is then shut down and the hose disconnected from the swivel and the drill rod removed from the hole. The drilling equipment is replaced with sampling equipment and a sample is taken directly through the drilling mud. Another method that can be used to advance the boring in caving or squeezing conditions is the casing method. In this method, a large diameter pipe is driven into the ground below the depth of the boring. The hole is then cleaned out using either the auger method or the rotary wash method. The casing supports the side of the hole and samples can be taken in the undisturbed soil below the casing. So let's summarize. There are many types of drilling and sampling methods. In this presentation we have presented a few of the most common methods: the solid stem auger method with an open hole, the hollow stem auger method, and the rotary wash boring method, which can be used either with or without a casing. Each method has its pros and cons, and there is no one best method. The drilling method selected will depend on a number of factors, including the location and accessibility of the site, the type of project and its objectives, and the soil conditions. Samplers can either be driven in with a drop hammer or pushed into the soil. Here I've provided some references and links to drilling and sampling videos that you can find online. I hope you've enjoyed this presentation and it's improved your knowledge of drilling and sampling.
ಇದ್ರೊಳಗೆ ಏನೂ ಗೊತ್ತಾಗಲ್ಲ. ವೈಟ್ ಒಂದೇನೋ ಟೇಪ್ ಹಿಡ್ದಂಗೆ ಒಂದು ಗೊತ್ತಾಗತ್ತೆ. ಹಾಂ ಅದಾದಷ್ಟು
ಬೇಡ ಬಿಡು.